Hi, the purpose of this video is to show how to take a volume that's stored on NFS and made use of by a VM on KVM, how to take that volume and migrate it to a managed storage, primary storage in CloudStack. And so we can see here under the Instances tab, I have a single virtual machine running on KVM. I'll go ahead and click on its name, and I'll take a look at View Volumes. I'll click on the name of this one and only volume, the root disk, and we can kind of scroll down here. We can see that it's on shared storage, which I just highlighted. The hypervisor is KVM, and if we scroll down here, we can see under storage, it's on a primary storage called NFS-2. So let's switch over to the Infrastructure tab, go into Primary Storage, and at the top we see NFS-2. I'll just go ahead and highlight that row. We can see this is an NFS share, and it's in use for Cluster 2. Let's click back on that Infrastructure tab and go take a look at our clusters. I just have two of them, and the second one is called Cluster 2, and it's a KVM cluster. So what I plan to do is demonstrate how to take this volume, the volume for this one and only virtual machine, and move it to another primary storage, a special type of primary storage called managed primary storage, which we'll take a look at in just a moment. Clicking on the Infrastructure tab again, and going back into primary storage, let's go ahead and add a new primary storage by clicking on the Add Primary Storage button in the upper right-hand corner. Now, in this situation, I want to add primary storage that's based on the SolidFire storage plugin. And this is known as managed storage because for every virtual disk that we need, we will create dynamically a volume on the SolidFire cluster to support that virtual disk, which we'll see as time goes on here. The first option I want to change in this dialog is the scope. I'd like to make this zone-wide primary storage. And although I intend on only using this for KVM, we want to select any as the hypervisor. I just have a single zone, so that's already selected. That looks good. I'm going to put a name in, maybe just SolidFire-1, SF-1. The protocol will be custom. SolidFire, in this particular case, was selected by default. Now we can check the Managed checkbox, or we can just leave it unchecked. As it turns out, this particular plugin, the one called SolidFire, supports managed storage in CloudStack. It does not handle what's known as sort of traditional or non-managed storage in CloudStack. So whether this checkbox is checked or not, this particular primary storage is going to be known to CloudStack as managed primary storage. So what we want to do here, now one of the unique characteristics of a primary storage like this is that we're not pre-allocating a share on some kind of a NAS system or a volume on an iSCSI SAN. What we're doing here is we're making use of an iSCSI SAN, but we're not creating any volumes up front. We're telling CloudStack how many bytes and how much performance it can use as needed to create volumes on the SolidFire cluster. So for example, let's say you spin up a virtual machine, its root disk requires 20 gigabytes. That will require us behind the scenes to create a SolidFire volume that's 20 gigabytes to support the root disk of that virtual machine. So as long as we have enough capacity and performance to create that new volume, we can continue doing that. So here, for bytes, I actually have this, since it's not specified in gigabytes, it can be, ends up being a really large number in many cases. I actually have this set up to be, I wanted to give CloudStack 2 petabytes of storage. So I'm going to just go ahead and copy that really large number and paste it here. Now for capacity IOPS, I want to give CloudStack permission to use up to 4.5 million IOPS. So I went ahead and entered that information into that text field. The URL field is a collection of key value pairs, and these are very vendor specific. In our case, I again have this in a text document. This provides information to CloudStack like what is the IP address on the control path for the storage area network? What's the IP address on the data path for the storage area network? What are the credentials I can use when I need to create volumes and items like that? And some other default values that I'm allowing us to specify. I'm going to go ahead and copy this and then paste it in the URL field. And at this point, I probably should point out, and it's easier to go to the document to show it here, there are 3 values at the end that we're providing. One of them is related to minimum IOPS, the next to maximum IOPS, and the final one to burst IOPS. So for every SolidFire volume, you specify not just the size that you'd like for that particular volume, but also its performance characteristics in terms of the minimum required performance, the typical maximum, and what's known as a burst value. What we're saying here is, and I went ahead and highlighted it, if the administrator or the user does not specify a minimum number of IOPS, the system will assume to create the volume with 1,000 minimum IOPS. Likewise, I'll highlight it, 2,000 maximum IOPS, and the burst will be calculated by taking the maximum IOPS and multiplying it by 1.5. So we'll see where these defaults come into play later during our migration demo, so I wanted to point them out right here. I'll go ahead and click X just to get out of that. I'm going to provide a storage tag now, and the one I picked is an existing one, st_a. This actually matches the storage tag of the NFS primary storage that is housing the root disk of our virtual machine. So those two match up. I'm going to go ahead and hit the OK button, and in a moment we'll have created primary storage that's zone-wide and based on the SolidFire storage plugin, which controls managed storage operations. So again, for example, the creation of a virtual disk will lead to the creation of a SolidFire volume that backs that virtual disk, and that is done dynamically. It's done as needed when you spin up a virtual machine and it needs a root disk, or say when you create data disks and attach them to virtual machines. So those operations to create volumes, to delete volumes, are all done dynamically. Now let's go and migrate that root disk from, I'll highlight it, NFS-2 to SF-1. We'll switch over to the Instances tab. The first step here is to shut down the virtual machine. This, at least at the time being, needs to be an offline migration of data. Now that our virtual machine is stopped, let's click on the name of the virtual machine. I'll click on View Volumes, and in the Quick View column, I'll hover over that, and I'll say Migrate Volume. Now we can see here, as I click on this combo box, in this particular case there's only one suitable primary storage that we can migrate our volume to. and we will go ahead and hit the OK button to initiate this process. Let's take a look now using the SolidFire GUI and track this track the progress of the data migration. Right now I'm on the Reporting tab. I'm going to switch over to the Management tab, and we can see here we have a row. I didn't show the GUI previously, but there was no row here before we initiated this migration process. So this row indicates a volume, and we can see the name of this volume is root-5, which is the name of our root disk, our virtual machine's root disk. We have automatically placed this SolidFire volume in a SolidFire account that maps to a CloudStack account, the one that owns that virtual machine. Under access groups, we can see we have what's known in SolidFire terminology as a volume access group or an access group. This is somewhat similar to access control list concepts. If I were to switch over to the Access Groups tab, we could see here that we have one volume that's inside of this access group and two initiators or hosts. So the 2 here to the right is in reference to each of my 2 KVM hosts. And the 1 over to the left is in reference to the new SolidFire volume that we created dynamically, which is now being populated with data from the virtual disk that resides on the NFS share. So if I go back over to volumes, scroll a little to the right, under Actions, click View Details, and we can see here how our I/O is coming along. So to the right, we'll see in a moment as the data comes in. We are in the process of doing a lot of writing to this particular volume. It has not yet completed the process of migration. If I switch back over to the Volumes tab in the meanwhile, I'd like to point out, if we look at the minimum IOPS, we have 1,000 4K min IOPS for this particular volume. Now, what happened is we were migrating a volume that was created from a compute offering that existed before we added that primary storage that was based on the SolidFire plugin. Now that primary storage that's based on the SolidFire storage plugin understands concepts like minimum and maximum IOPS. Prior to that particular primary storage and the SolidFire storage plugin that supports it, there was no concept of this in CloudStack. So it makes sense that our old compute offering didn't specify a minimum and maximum IOPS for that volume that we're in the process of migrating. So what happened here is, since those values were not specified, we assumed 1,000 for the minimum IOPS and 2,000 for the maximum, and we calculated burst by taking the maximum and multiplying it by 1.5. Now those numbers, 1,000, 2,000, and the 1.5 multiplier, were provided, as we had seen a little earlier, as part of those key value pairs in the URL field when we added primary storage to CloudStack that was based on the SolidFire storage plugin. So that's how these numbers kind of came to be. And also to point out the size here, we were actually dealing with a 20 gigabyte root disk that we're migrating, and so that's why we see here that the underlying SolidFire volume that's going to be supporting that virtual disk in the future is also 20 gigabytes. So let's switch back. If I scroll to the right, go to Actions, View Details, and we'll see in a moment as this chart populates again how the I/O progress is progressing. Okay, so we see we're not complete yet with the migration. What I'll do at this point is pause the video and come back when the migration has completed. Okay, our migration has completed. Let's switch back over to the CloudStack GUI. And we can see here we have our virtual machine. I'll go ahead and click on the name. I'll click on View Volumes. I'll click on the name of the volume, and if we scroll down, we can see that we are now on primary storage SF-1. So let's go ahead, I'll click on the Instances tab and go to the Quick View column and start up this instance. If I switch over to one of my KVM hosts, I'll just pick the top one for now, and we'll see here if I guessed right. Oh, it looks like I did. This VM is now coming up on this particular KVM host. I'm going to click on this command prompt window and actually rerun ls-l. And I wanted to point out a few new rows here. I had run that command before, and now this is after we have our virtual machine with its root disk running on the SolidFire SAN. What we'll see here is a reference to an iSCSI volume that resides on the SolidFire system. So just wanted to point out, then when you shut the VM down, what happens is the VM disappears from the point of view of the KVM hypervisor, and these rows themselves will disappear as well. So let's go ahead and take a look at CloudStack again under the Quick View column, View Console, and we can see that we're booting up. So we'll let this go for a little while, and I wanted to point out that you can go ahead and actually resize the root disk, both in terms of the actual capacity, but also in terms of its performance. So if we take a look again, I'll click on the name of this virtual machine, View Volumes, the name of the volume that we have, and I scroll down. You can see again, because we came from a compute offering that did not have any specifications for min or max IOPS, that CloudStack is not aware of the performance characteristics of the supporting SolidFire volume. Now if we went to the SolidFire SAN, the GUI, clicked on the Volumes tab, we can see here again we have 1,000 minimum, 2,000 maximum, 3,000 burst IOPS. Now let's say we'd like to change that. Maybe that's too little or too much. And in fact, maybe you actually had very high values for minimum, maximum, and burst when you performed the migration. So what we'd like to do at this point is go ahead and change the minimum and maximum and burst and actually make sure those values show up within the CloudStack database and the user interface. So I'm going to switch over to my command prompt here, and I'm going to use CloudMonkey. I'm going to run a command Resize Volume, and I'm going to specify min IOPS of 200 and max IOPS of 400. I'm going to hit enter, and this doesn't matter if the volume is actually being used or not. It only matters if you're actually resizing the volume in this, the capacity of the volume in this case. If you're just changing the performance characteristics, the volume can be in use. So I'm going to hit the enter button, and in a moment, let's see here, I'm missing an argument. Oh, I'm missing the volume ID. So let me actually switch back over to the CloudStack GUI. That makes sense. And go ahead and copy this particular ID, switch back to my command prompt. I can just place it anywhere here in the list of arguments, and let's run that again. So we can see that the command is being executed, and I'll highlight a subset of the results. The maximum IOPS are now set at 400 and the minimum at 200. So if we go back to the CloudStack GUI, and refresh this screen, I'm just going to click on the Storage tab and then click on the name of the virtual disk. I'll scroll down a little bit here, and we can see that we have 200 minimum IOPS and 400 maximum IOPS. Let's confirm that on the SolidFire side. We're in the SolidFire GUI right now. I haven't refreshed anything yet, so we still see the old values. Once I hit the refresh button, we can now see the new values. Thank you for watching this video on how to perform volume migration with KVM as it pertains to managed storage.